Okay, so for the next lab experiment we're doing, potential kinetic energy, we're using this device that you see here. It's this big long rail of a thing. It's called the air track. Okay, so if you can hear some kind of buzzing in the background, some kind of blowing sound, there's air being blown into this through a hose continuously. You see a hose there kind of on the left hand side. There's an air supply built in this lab room, and so there's air continually coming out of this, okay, out of this air track. This here, see this red thing? This is a glider. That's what we call a glider. And I can put it on the air track and it'll float around. So you see the glider floating around, right? So it's riding on the air that's coming out of the track. So that enables the glider to move around with very little friction. So if we can have motion with no friction, then that makes things a lot easier. It's a lot easier to figure out what's going on. Unlike with the IO lab, we were not able to eliminate it. But with this, we can. In the real world, you never really get totally rid of all friction, but it comes pretty close, good enough that we think we can neglect friction. So that's the main reason we use this. Okay, so now let me come in a little closer and I'm going to give you a more close-up view of what this looks like. Okay, so now you can see it's this big long rail of a thing, and I can give the glider a push and move it, and it'll float around. Now these black things you see, those two kind of brackets there, those black things, those are photo gates. And what they do is they can be connected to the computer and you can measure time as the glider passes through. So the glider has this cardboard flag on it, and whenever it goes through the gate, okay, there's a beam of light inside the photo gate. And when the glider goes through and blocks the light, it measures, the photo gate measures how long it's being blocked. So if the glider, let's say the glider is moving through here, okay, and it times it, okay, so it measures the time that it took for the glider to pass through because of the cardboard flag was blocking. And when you know the time and you know the length of this cardboard flag here, then you can just say that length divided by the time and get the velocity, all right? So there are two photo gates. See that there are two of them there. There's another one over there on the left. So what that means is that at two locations along the track, we can measure times and get velocities, okay? So we can know velocity at two different points on the track. We can't really know it anywhere else. Well, we can't measure it anyway, but if we can get it at two locations, that enables us to do some nice little experiments. Okay, so now I've added something to the setup. See the glider now, and notice horizontally you'll see something black there. There's a piece of tape attached to the glider. Let's see if I can get a little closer. So we're sort of doing what we were doing in the IO lab experiment, where we attached a pulley and a string and pulled the IO lab up the ramp. That's kind of what we're doing here, except now it's a piece of tape. And so there the piece of tape is draped over what we call the air pulley, which is that curved piece at the end of the air track. Okay, so just follow it down and you'll see a weight attached on the bottom of this tape. Okay, so I don't have the air turned on right now. If I did, it would be moving, but when we turn the air on, then that tape, or that weight is going to fall and pull on the tape, okay, and then it'll pull the glider to the right in that way. All right, let's get a closer look at the air pulley, see where the tape hangs over the pulley. Now that air pulley, as we call it, which is just that curved piece, there's no wheel that turns like there is with a usual pulley, but the air pulley, it has air coming out of it as well, like the track does. So the tape can slide over the air pulley with very little resistance, very little friction. Okay, so that's how that works. All right. Okay, so here's another view where you can see the entire air track again, but this time with the tape and the hanging mass attached to it. The air's turned off right now, but when I turn it on, what will happen is the hanging mass there on the right will fall, and the glider will of course be pulled to the right. And we can get velocity from those two photo gates. Not directly, we get time from the photo gates, but we can calculate velocity from that. So the velocity is going to be bigger, greater there when it passes through photo gate 2 than when it passes through photo gate 1. And we can get kinetic energy from velocity, which is what we're interested in this experiment. Okay, so I'm going to turn it on really quickly. Watch there on the right, the hanging mass. Watch it fall when I turn it on. Okay, now you notice too that the glider bounces back and forth a little bit after it makes its initial trip along the track. The initial trip is probably all we really care about. We get our data then. The bouncing back and forth just happens, but we don't really care about that so much. Okay, so everything that I've talked about so far has been with the air track in a level position, okay, where it's level with the table and level with the floor. But now what you see is that it's been raised on one end, okay? So the air is turned off right now, but when I turn the air on, what would happen is the glider is going to coast downhill down the air track. So that's pretty obvious, right? That would happen. And what we could look at in that case would be the conservation of energy, because now that the glider is capable of changing height, we can talk about it having potential energy due to its height. So it's going to travel from a larger height to a lesser height, so from a high place to a low place. So you can talk about it losing potential energy as it does that, and then that potential energy loss would show up as a kinetic energy gain. It would go from being motionless to moving at some velocity. So you just get an exchange of energy. The total energy is conserved, but it will change from one kind of energy to another. Okay. Okay, so now we've changed things yet again. So look what's happening now. I've got the tape back on the glider and with a mass hanging over the edge of the right hand end of the air track. Okay, it actually seems to be wobbling a little bit now, but that's all right. So I don't have the air on right now, but when I turn the air on, what's going to happen is, like it was before in the level case, the mass will fall downwards and pull the glider uphill, okay, up the track. So then you can talk about all sorts of energy changes going on, and it gets more complicated now. The glider would experience an increase in kinetic energy as it goes up the track. It's going to be getting faster because it's being pulled, but it would also increase potential energy in this case. Okay, so that seems a little counterintuitive at first. We're talking about energy gain. How does that happen? Well, when you look at the hanging mass, it comes into play too. It's part of the whole system. So as it falls, it's going to lose potential energy. So that's where the energy comes from that's being used to move the glider. And it'll have kinetic energy too because it's moving. So now you get all sorts of stuff going on. You've got potential energy and kinetic energy for both the glider and the hanging mass. So it's all going to add up. But when you look at everything, total energy would be conserved in the total system. And if I turn the air on, you're going to see it fall. I'm going to do that really quickly. Okay, so now let me talk to you for a minute or two about what the lab process will be like next week. So it's different than it usually is. Last week, you remember that we told you you only have to attend lab for 1 hour this coming week. All right. So if you normally work in room 103, then you just come the regular time that your lab meets, but you only have to stay for 1 hour. Okay. If you normally work in room 105, then you don't have to attend until the second hour of your usual lab period. Okay, so you just come the second hour then, and you're only there for an hour. All right. So what you'll do is, because time will be valuable, we'll want to conserve that as much as we can. You'll get all the measurements for the experiment and do as much of the calculating as you can. You might not have time to finish all of that in that hour, but you'll at least get all the measurements and some calculating, and then you can leave. Okay, now if you want to sit out in the atrium area or somewhere like that nearby and continue working on the rest of the calculations and finish them, you are certainly welcome to do that on your own time, and you can probably get the instructor or the TA to help you if you need some help with that. Of course, their first priority will be helping people that are in lab at that time, but they'll probably be glad to help you too with if you want to stay over and see if you can finish calculating. Okay, you'll just have to be outside of the lab room though when you do that. All right. So okay. So now instead of turning the experiment in when the lab is finished, as you normally have been doing, what you're going to do is take your data home with you, and then you write up a report on it, okay? And you turn in the report the next time the lab meets, okay? So now for that reason, because you're going to take work home with you, there's a couple of security things we have to do. So you'll have to have your measurements in ink before you leave, written down in ink, okay? So that presumably they can't be changed. And then you get it signed by the instructor or the TA, all right? So that makes it official that you got this data actually being physically present in lab. That's where you got it, all right? So that's what the deal behind that is. So that way, if some person, heaven forbid, were to not come to lab and just make up some stuff at home and then try to turn it in, well, we would catch them that way. We would know that they weren't actually in lab. They didn't get it there. Okay, so it's a little bit of a pain in the neck, but it protects you. You're going to be there doing it the way you're supposed to do. So it makes sure you get your credit that's due to you for being there and working in lab. All right. So now the report, there's some pages in the lab manual that will show you and explain the format of the lab report. It's not a real big, horrible, complicated deal, but there are a few requirements. So that's in the lab manual, and we'll direct you to that later and tell you more details about that later. But it's going to involve answering some questions, documenting your calculations, showing your calculations. So a little bit of analysis work. Sometimes it involves writing a discussion, okay? Sometimes it involves doing some graphs, not this time, but some other times it will. So it involves several things that you do for the report, and we'll share more information about that later, okay? This is all in the lab manual. The experiment is also in the lab manual that you bought in the bookstore. I don't need to send you anything this time, so don't expect anything like that. It's in the lab manual. And you don't need your IOLab device either for this experiment, so you can leave it at home if you want to. All right, so we'll see you next week.